All right, lesson 1-7. We have two learning objectives today. Today we're going to learn about two things. I'm going to actually go out of order here. Learning objective or learning goal number 2 is that I can prove whether a polynomial is even, odd, or neither. We're going to start there. The first half of the lesson is going to be talking about what is an even function, what's an odd function. And then where we'll end is we'll talk about this idea of end behavior. Those are the two things we're going to look at today. First, we're going to look at even and odd. So on your first slide, what I want you to draw attention to, you can read this on your own later, is this equation right here. This is the mathematical language that proves if a function is even. A function is even if this math language is true. Now you probably, I'm guessing, 7 lessons into the school year aren't necessarily the best yet at translating this math language to English words. So you can read on your own what it means, but I'm going to show you a picture to make sense of this, because I think with the picture you'll catch on quicker. But this is the math language that has to be true for a function to be even. Now, right now, again, you're probably looking at going, what does that mean? So let me show you. Go over to your next slide. And what we're going to do is just guess some values on this function. This right here is an even function. Let's take a guess. What x value, Yobani, I'll let you throw out a value. You can pick any value you want. What x value do you want to be represented by this point right here? For x. He says -5. And that's a great pick. The reason it's great is because he gave me a negative number. If he gave me a positive number, that's about the only thing he could have said that would have been incorrect. But he gave me a negative number. I'm great with 5. Okay, for a y value, let's choose any number that's not a 5, because I don't want you to get confused. So any number that's not a 5, that's positive. How about 7? Let's put that as a value of 7. Now here's what this means. If a function is even, from the math language, this language right here, if a function is even, and you have the point -5, 7, if the function is even, you will also have to have, requirement, a +5 with a +7. You must have that. So here's the math language. Let me plug this in. This is saying if you have a function that's evaluated at a positive x value, what x value is our positive right now? 5. That when you evaluate that function, you will get the same value as if you evaluate the function at the negative of it. What's the negative of 5? -5. You will get the same value. Now, what do we get on both f of -5 and f of 5? What is the y value? 7. So I want to put it equals 7. They both equal 7. Therefore, this is an even function. Because when you compare the opposite x's, you get the same y. So an even function, you can think of it that way, is I'm going to just click right here and type that in. An even function, even functions have the same y value when evaluating opposite x's. So that's what makes a function even, is when you have the opposite x values, you'll end up with the same exact y values. Opposite x's produce the same y value. Okay, so that's your that's going to be for even functions. Okay, so now let's take a look at what an odd function is. Here is an example of an odd function. Again, circle up the equation right here. This is the equation that we would use to prove something is an odd function. Circle that up. But right now, I'm guessing when you look at that, you're not able to translate those math symbols to necessarily like English words. So let's do it together using this graph. So once again, we're going to pick this point here. Let's go Devonte this time. You choose an x value that you think could be represented by this point right there.
-9.
He says -9, and that works because it's a negative number. That's great. -9 is a great value to say that is. Now let's pick a y value here. What y value do we want to say that is? There, just don't give me the number -9. I don't want anybody confused. What number should we say that is? Let's do something other than -9. Stephen, what do you think? What y value could represent this point right there? He says -5. Let's make that be -5 right there. So we have the point -9, comma -5. Now, if this is an odd function, what has to be true is if we're looking at the point -9, comma -5, what has to be true is we're going to have a point. What should we make this x value? A 9, a +9, and a y value of +5. That if you evaluate the function at the -x, what's my -x? -9. The value you get. So f represents the y value. The y value you get will be the opposite of the y value you get at +x. What's my +x? 9. Let's check this out. Let me see what's the true correct answer here. So f of -9. What is the value, the y value, or the function f evaluate at -9? What y value should be generated? A -5. This should equal -5 over here. So the function evaluated at -9 we know is -5. What this is saying, the negative of the function evaluated at 9. So what is the function evaluated at 9 produce? A 5. A +5. But once you make it negative right here, it becomes a -5. That's an odd function. So in English words, an odd function occurs when opposite x values produce opposite y values. So in summary, if opposite x values produce the same y values, it is a even function. If opposite x values produce opposite y values, it is a odd function. There's an option of neither. Neither would be when opposite x values produce two random y's that aren't related to one another. All right, we're going to look at 3 different types of these problems. We're first going to look graphically. Oh, I just realized I forgot to say. So graphically, what happens on an even function is that an even function will be symmetric with respect to the y-axis. This will be symmetric with respect to the y-axis. An even function is symmetric with respect to the y-axis, meaning if you cut the graph along the y-axis, you'd have 2 parts that were equal but mirrored of one another. The graph would be exactly the same, just mirrored, the same exact dimensions and all that, just mirrored on the y-axis. So if a function is even, it's symmetric with respect to the y-axis. If a function is odd, next slide. If a function is odd, it is symmetric with respect to the origin. So an odd function is symmetric with respect to the origin. An even function is symmetric with respect to the y-axis. Okay, so now we're going to look at some graphs. Based off symmetry, make up our mind whether a function is even, odd, or neither. So this first example, 1a, what do you think? Even function, odd function, or neither? You can go off of symmetry. Does it look like it's symmetric with respect to the y-axis, symmetric with respect to the origin, or no symmetry whatsoever? What do you think on the first one? Does this, meaning you could look by symmetries, we could do points, we'll do points today. Is this symmetric? Could you cut the graph in half? And if you could, what would cut the graph in half? The y-axis or the origin? The y-axis. If it's symmetric with respect to the y-axis, it is a even function. This is an even function. And by points, you could prove it by choosing 2 points. They should have opposite x's, but the exact same y value. I'm going to choose these values here. This is, the x-axis is counting by 2s. That means if this is 0, this is the value 2 right there. This point has an x value of 1. What's the y value? 0. And at -1, we have the y value of 0. You can see that this is an even function because opposite x's have the same y. Opposite x's have the same exact y. That would be even function. Okay, let's go to the next one. Does the next one have symmetry with respect to the y-axis, or does it have symmetry with respect to the origin, meaning like diagonal, or neither? No symmetry. No symmetry. So if it has no symmetry, what type of function is it? Neither. So neither even nor odd function. Neither an even nor odd function. Oh, I didn't spell it right. There we go. Neither an even or odd function. Now, a way to prove it would be to select a point. This point is not exact, but I'm going to approximate. Approximately, what's my x value on this point? Get your phone back out. Come on. Approximately, that's a value of 4. What's the y value? 2. Now, if this were an even function, what point would it also have to have if it were even? -4? No, that would be odd. If it was even, it would have to have opposite x, same y. It would have to have -4, +2. Put a point there and say, put even here. If this were an even function, it would have to have a point there. Does the graph have a point there? No. If it were an odd function, it would have to have opposite x and opposite y. So we'd have to have -4, -2. It would have to have -4, -2 if it were odd. Whoops, I'm starting to write the point. Put odd there. If it were odd, it would have to have that point. Does this graph travel through either of those 2 points? No, therefore it's neither. That's how you can tell graph. Okay, we've come to your first DOL. What I want you to do is use this picture, state if it's even, odd, or neither, and once you decide, pick a point, or 2 points, I should say. Pick 2 points to prove why it's either even, odd, or neither. Okay, so again, state whether it's even, odd, or neither function, and then find 2 points that confirm what you say is true. DOL number 1. All right, so now we've seen table function, we've seen a graph and we've looked at if it's even or odd off a graph. Now let's look at tables. I'm gonna make a change here. Second semester is when we'll deal with these trigonometric functions. Cos, you might remember from geometry, cos stands for cosine. We're not gonna do that today. Change this to an x squared. And change the sine to an x cubed. Okay, so we're going to change, I'm going to leave the coefficients, but I'm just going to change those. Now let's go look at tables and see what we come up with. So on your calculator, press, get to your home screen, do new document, don't save if it asks you. Mine already cleared it, so I'm back here. Choose a graph, and let's graph these and see what we come up with. So 5x squared, 5x squared, and then plus 4 on the outside. Whoops, 5x squared plus 4. How do we get to a table? Do you remember? Control T. All right, I'm going to get to these values here. All right, y values. What y values are you getting at -2? 24. Okay, we're getting the same as me. Good. That's a 24. This is a 9, a 4, a 9, and okay, here's the rule. To check for even or odds, you have to pick any 2 x's that are opposite of one another. So really the first point you pick does not matter, other than you cannot choose 0. 0 you cannot determine anything from. So any x value other than a 0. Joshua, I'll let you be the one to pick. Which x value other than 0 do you want to start with? He says -2. Now that's fine. You can choose anything you want to be your first point. But once you choose your first point, you have to choose the correct second point. There's only one option. If you chose an x value of -2, what do you also have to choose? +2. Compare those two. At opposite x's, what can we say about the y's? Same y. If you had the same y, it's an even function. This right here is an even function. Opposite x's produce the same y. Okay, now let's change our equation to 5x cubed. I'm going to press Control T to drop my table, press Tab, then up to change my equation. So I'm looking at 5x cubed. So I need to change that power to a 3 and leave everything else gone. 5x cubed. Press Enter, and again, press Control T to pull your table back up. All right, what y value are you getting at -2? -40? What y value are you getting at -1? -5, 0, 5, and 40. Okay, so when we test even or odd, the only x value you cannot choose is 0. Other than that, you're clear. Brittany, I'll let you choose. Which x value do you want to start off with? She says 1. If we choose a positive 1, which is the point 1,5, what x value must we choose for the second point? The x value of -1. We have to choose that. So when you compare it this time, opposite x's produce opposite y's. If opposite x's produce opposite y's, what type of function is it? This is an odd function. If opposite x's produce opposite y's, then it's a odd function. Opposites, the odds, sorry, the o's go together. If it's an odd function, you're going to have opposites on the y's. All right, one more. Press Control T to drop. Press Tab. That'll pull up your equation. And now let's graph this. I need -5x to the 5th power minus 4x squared. Hit Enter, and then again Control T. All right, I'm getting y values. Are you getting the same as me? 144 when x is -2? One at the value -1, 1, 0, 0, 1, -9, and 2, -176. All right, we can choose any x value whatsoever other than 0. Joe Nathan, which x value you want to choose this time? If we choose -1, now the second point is essential. Where we had all the freedom in our first choice, the second choice, you do not have any freedom. You must also select +1. Compare your y's. When you choose the opposite x's, what happens with my y's? Completely different, random, not even compared. So what does it mean if there's no relationship? Neither even nor odd. So now we've taken a look graphically. We've taken a look using tables. There's one more thing you can do to determine if something's even or odd. There's a third way, and that's you can just look at the equation in general. The equation itself can tell you if it's even or odd. How you determine is you look, and every single power must be an even power to be an even function. Every single power must be odd to be an odd, and neither means you're getting mixed up and you have them mixed in between. Now, there's one trick to this. That's this. If you see a constant for the sake of even functions, odd functions, you need to think of it in terms of being x to the power of 0. Now, that is a even number. The definition of even means if you divide it by 2, you get a remainder of 0. What's 0 divided by 2? 0. If you divide by 2 and you get a remainder of 0, it's even. Those are even. The definition of odd is if you divide it by 2, you get a remainder of 1. So on this one, what can you tell me about my powers? Even powers, odd powers. Every power is even. Every power is even. If every power is even, what type of function is it? It's an even function. This is an even function. Now again, the one thing that's tricky about equations is you need to remember that if it's a constant, that means it doesn't have an x at all, you put x to the 0 with it. Part B, what are my powers this time? These are all odd powers. Every power is odd. If every power is odd, guess what it is? It's an odd function. Now you have a second DOL. What can you tell me about the powers this time? We have 2 even powers and 1 odd power. What does that mean if you have both even and odd? You got it. All right, that's a wrap on the first half of the lesson. This is our first learning goal, that you can observe or define or describe functions as being even, odd, or neither even nor odd. So that's the first task, okay? If you went back and you looked at these equations here, you could have seen why they were even function. Why is this an even function? Because this is x to what power? Squared. And if it has just a +4, you could say that's like plus 4x to the 0 power. Both of these powers are even. Here, I only had 1 power. It was a 3. 3 is a odd number. That's an odd function. And this one had a power of 5 and a power of 2. Therefore, since 1 power is even odd, 1 power is even, this is neither. I mean, you can go back and check it, and you'll see that that always works. All right, second thing we're going to do now. We're going to talk about in behavior. Now, in behavior is an English word. That's an English statement there, in behavior. It's talking about what's happening on the graph as we go to the left and the right, or as x increases or decreases without bound. Mathematically, we will describe this using a limit. Circle the word limit and point it at in behavior. A limit is a mathematical symbol we will use to describe in behavior. So let me say it this way. If you come across a word problem is a math problem that's given you English words, they would use the term in behavior because that's the English word. However, if you had a purely math problem or it's just math symbols, they would not say in behavior, they would use a limit. Now I have a typo here. What is true is what I describe here. In almost all cases, a limit will either A, increase without bound, B, decrease without bound, C, approach a horizontal asymptote, or here's my typo. This should say D. I wrote A, B, C, and then 4. Instead of A, B, C, 4, how about A, B, C, or D, approach a point. So a limit will either increase, decrease without bound, approach a horizontal asymptote, or approach a point. You will hear me say them this way. It'll either A, rise. You'll hear me just rattle them off. The graph will rise. B would represent the graph will fall. C, the graph will get flat. Or D, the graph will come to a point. Whoops. D. Or D, the graph will come to a point. Those are your options. Now, while we deal with polynomial functions, we will only get answers that are rising or falling. That's all we'll get. But that's that. Now, what I want you to think of with the limit, whenever you hear me say this about a limit, I want you to think about this. A limit does not tell you where the graph is. A limit tells you where the graph is going. So I want you to make a note of that. A limit does not tell you where the graph is. A limit tells you where the graph is going. The whole point of a limit is to tell you where a graph is heading off to. So early on in the school year, what that means is we're going to be looking for arrows on a graph. If you see an arrow on the graph, what's it telling you, the arrow? Does it tell you where the graph is? Or is it telling you where the graph is going? Where it's going. That's when we're going to write limits at the beginning of the year, is where we see an arrow. Now, later in the year, we're going to change this a little bit. But for most of the year, or most of the times, a limit's going to describe where the graph is going with an, like you're looking for an arrow. Okay. With that, I'm going to make a change to this next slide to make sense of this. There's three equations right now. They all say f of x equals f of x equals f of x equals. Let's do this. On the second one, I'm going to change this to a letter G. And the last one, I'm going to change to a letter H. And the reason I'm going to do this is so when we write our answers, we're not confused at what's what. So I want to change this to a letter H. Okay, so on this problem, it says here, express the end behavior. Now, this is an English statement. Express the end behavior. That's, they use that word of each function using the mathematical notation of a limit, meaning if I showed you this, you would write it using a limit. So on this first picture, they did not give us arrows. I'm going to add arrows. This graph should have how many arrows on this picture? Two. One up here and one down here. Now, each arrow, we're going to use a limit to describe. I put a 1 there, and I'm going to put a 2 here, because I'm going to write two limits. I want to make sure when you compare your answers, you can see what I'm talking about. So limit 1. The way you would write a limit using mathematical notation is you write LIM. Lim stands for limit. And then you'll put the name of the function, which in this case is f of x, equals. And then underneath you'll have an x with an arrow. And now what we're going to do is fill in two values to represent where this graph is going. So let me show you what would be wrong. What would be wrong is to pretend that this arrow is telling you where the graph is and to put a coordinate point saying, okay, that arrow is kind of pointing left. Well, that means the x is going to go to negative infinity. And because it's going up, the y value is going to infinity. If you did it like this, this is wrong because a parentheses around the values, that tells you where the graph is. Is this graph literally at negative infinity, comma, positive infinity? Is it literally right there? No, but is it going there? Yes, so here's how you write this. You don't put this way. What you do is when you write a limit and you say, okay, where is the x heading towards? Well, it's going to negative infinity, meaning this arrow is going left. Now, if we were to get left forever, what y value would we arrive at? In positive infinity. So that would be the correct way of writing a limit. You would write a limit to describe this arrow because the arrow doesn't mean the graph is there. The arrow means it's going there. And if you're talking about where it's going, you use a limit. So now I'm going to put in English words to describe this. What is happening? We are saying as the x goes to the left, I'm going to put that in parentheses. As the x goes left, this graph rises. As I go left, the graph rises. That's what these symbols mean. As my graph approaches negative infinity on the x, that means as I go left without bound, as I go left forever, the graph, what does it do? What are the four options? Does it rise? Does it fall? Does it get flat? Or does it stop at a point? What happens as I go left? It rises. And that's why your y is in infinity for rising. Your x is in negative infinity, meaning goes left. Make sense? Now, the parentheses are not a part of the answer. That's just me describing in English what's happening. Okay, let's try this again on the second limit. This second arrow right there. Again, you would have LIM, f of x equals, with an x arrow underneath. Now tell me about this arrow. Does this arrow head to the left or to the right on the x value? It's going to the right. What does that mean for x values? If you go right, is it getting bigger or smaller? If you go right, x's get bigger and bigger and bigger. So you would put a positive infinity because x is getting bigger. It's increasing without bound. Now, as this graph goes to the right, does it rise? Does it fall? Does it get flat? Or does it stop at a point? Which option is true? It falls. The symbol for falling would be a negative infinity. And now I'm going to put the English words in there. We fall as we go to the right. Now, I'm not going to put those in every time, but that's just showing you what those symbols mean. Hey, Devontae, stay with me now. Make sure you're not sleeping on. Do you have that written down? All right, good. All right, let's look at the second graph. This second graph over here. I want to kind of separate these here. On the second graph, there's not any arrows. How many arrows should this graph have? 2 arrows. Good. 1 arrow there, 1 arrow there. So again, I'm going to circle 1 and a 2 just so you can see what each limit represents. Whoops. All right, limit 1. So right, LIM. This time I renamed it g of x. I did that just so you can see that the second part is telling you which function to look at. So I put LIM g of x, meaning this equation. Tell me about this arrow. What 2 directions is this arrow going? And the options are, how about this? Let me do it one at a time. Is this arrow pointing to the left or to the right? Which way is it moving, left or right? Left. What symbol for x represents moving left forever? Negative infinity. Good. As we move left without bound, meaning as we decrease without bound, what happens to my y values? Do they rise, fall, get flat, or come to a point? They rise. Put a positive infinity. Okay. Limit 2. LIM g of x equals with the next arrow. Now, what happens on this arrow? Which way is it moving? To the left or to the right for x? To the right. So if it's moving right, put a positive infinity. As x increases without bound, as the graph moves to the right, what happens to my y? Do they rise? Do they fall? Does it get flat, or does it come to a point? It rises, positive infinity. Those would be your 2 limits. Okay. Why does this graph only have 2 limits? How many arrows does it have? 2. 2 arrows, 2 limits. Okay, how about this last polynomial? How many arrows would this polynomial function have? 2. We have 2 arrows. I'll call this top one 1. I'll call this second one 2. So for the first limit, this I'm going to say LIM h of x equals, because I renamed it h, with an x arrow. This first arrow, does this first arrow move to the right or to the left? Which way is it going?
Right.
To the right. So if it's going to the right, what symbol do I put for x? Positive infinity. As our graph moves further and further to the right, does it rise? Yeah. Does it fall? Does it get flat or come to a point? It rises. So polynomial functions, which we're doing right now, only rise and fall. That's the only options for polynomials. It will not be the same starting after the test. We start looking at rationals. You'll have some flats and points. But for right now, all we're doing is either rising or falling. Okay. This second arrow here, what's it doing? Is it moving to the left or to the right? It's going to the left. So what symbol represents going left? And what happens as we move left? Does the graph rise, fall, flat, or come to a point? Falls. What symbol represents falling? Negative infinity. You got it. That's how you'd write that. Now notice, do I ever write x equals? No, because your x can never equal negative infinity or positive infinity. But if it could, then the y value would equal it. I'm assuming that's why they don't do an arrow there. But you need to know that on the symbols, it's always x arrow, not x equals sign. Do not put x equals sign. Also, it's essential that you put the symbol LIM. If you leave off the LIM, you will not get credit on the test. You have to remember LIM, which stands for limit. All right, last thing here before I move on, let's review from our first learning objective. First equation. You could look at the picture, but let's just look at the powers. Would you say, looking at the powers, that this is an odd function, an even function, or neither? When I examine the powers, that's a power of 5, power of 3. This does not show a power, but it does have an x. So since it has an x, what's its power? Would you say odd function, even function, or neither? This is an odd function. All powers are odd. Okay, next one. Power 6, power 4, power 2. Don't forget, if you have a constant, that's like x to what power? 0. 6, 4, 2, 0. Those are all even. This is an even function. Finally, the last one. Power 3, power 2, power 1, power 0. Neither. I'm just going to say neither even / odd. All right. I have a DOL for you. I want you to write these two. Let's call this first graph F and call the second graph G. If you're writing the letter on a graph, you don't have to put f of x if you don't want to. You can just put the letters f and g, but when you write your limit, you would write f of x, lim f of x equals or lim g of x equals. Okay, go ahead. Let's try DOL number 3. All right, as I pick up this graph, how many arrows could graph F have? 2 arrows. 2 arrows means how many limits? 2 limits. Right graph G, how many arrows? 2. So 2 arrows means 2 limits. Good. All right. Finishing this off. In summary, here's what you need to know. If you're doing in behavior, that's the limits that we just did. You only have to look at the leading term. So I want you to pair these up. If you're doing the in behavior, meaning the limits, if you're doing your in behavior, you only need to look at the leading term. If you're doing the in behavior, all you need to look at is the even term. Now, this is in contrast to what we did first. If we're doing even and odd function, do you only have to look at the leading term? When we did even and odd, do you only have to look at the leading term? That means the highest power term. Do you only have to look at that one? No, what do you need to look at? All of them. So even or odd, you have to look at everything. If you're doing in behavior, meaning your limits for polynomial, you'll only have to look at the leading term. So some examples here. Oh, here's a picture. You can look at that later. But this is just saying if your leading term has an odd power, it's going to look like an S-curve. If it's a positive term, it'll increase. If it's a negative term, it'll decrease. This is saying, using my hands here, this is saying if you have an odd degree, the highest power is odd, it'll look like an S. If that term that has the degree is positive, it'll increase. If it's negative, it will decrease. Okay, the bottom is saying if your degree is even, meaning the highest power is even, it's going to look like somewhat like a parabola. Positive, that makes it up. Negative makes it down. That's just a rule to look at later. Okay, I'm going to change my instructions a little bit. I'm going to do 2 things here. What I'm going to do first is I'm going to describe even or odd. I'm going to do that first. And then second, I'm just going to do a quick sketch based off the leading term. Quick sketch of leading term. That's what I'm going to do. And I might not even do the in behavior at all. So on this problem, first, I want to discuss if it's even or odd. Do you look at just the leading term or do you have to look at all the terms? All the terms. Is this even, odd, or neither? Neither. Neither even nor odd. That's great. Why is that true? Even and odd. The powers alternate. You have both even and odd powers. Great. Number 2, I'm going to do a quick sketch of the leading term. What is my leading term?
3.
Okay, here 3 and 4. Leading term would be not just the front number, the coefficient. It would not be just the power. It'd be the whole thing with the x. 3x to the fourth. So based off of 3x to the fourth, what would that look like? Would that be a parabola or an S curve if it was 3x to the fourth? Parabola. Is it a positive parabola or a negative parabola? Positive parabola. It should look like this, a positive parabola. 3x to the fourth would look like that. You only have to look at the leading term to figure out your limits. The whole equation would change the middle, but overall, 3x to the fourth, that's your leading term. That's going to determine the shape of the graph. And you could write your limits from here. I said I might not. You know what? I'll do it really quickly. So let's say LIM f of x equals x arrow. And I'll do it over here as well. I have 2 arrows, so 2 limits, f of x equals x arrow. Tell me about this first arrow. Does this arrow point left or right? Left. What symbol represents left? Negative infinity. What can you tell me about the y value? As we go left, does it rise, fall, get flat, or come to a point? Rises, positive infinity. Okay, now let's talk about this arrow. Does this go to the left or to the right? Positive infinity. Does it rise, fall, get flat, or come to a point? Rises. So that would be the answer there. So in behavior, you only have to look at the leading term, but to determine if it's even or odd, you would look at the whole, all the powers all the way down. Okay, let's do part B. Part B, what do you think? Number 1, is this an even function, odd function, or neither? This is neither. Very good. Why is it neither? We have a little bit of both. We have an even power and we have 2 odd powers. Therefore, it is neither. Good. Okay, second question I have for you. What is my leading term this time? Negative 3x squared. You hear that? It's not correct though. 2x to the 5th power. Is it positive or negative? Positive. So it's 2x to the 5th power. That's my leading term. So if that's my leading term, what does that mean about my graph? S curve or parabola? S curve. Positive S curve or negative S curve? Positive. I'm going to draw a positive S curve here. And we would have, again, 2 arrows means 2 limits. This function is called g, so I'm going to call it g of x. This arrow right here at the top, it's going to the left or to the right? Right, so positive infinity, agree with Joe Nathan. Now tell me, does it rise, fall, get flat, or come to a point? Rises, so positive infinity. Now let's talk about this limit on the left. Oh, I just gave that away. Is it going left or right? Left. It's going left. What symbol means left? Negative infinity. And is it rising, falling, getting flat, or coming to a point? It's falling, so negative infinity. That would be your limits. Do I have one more of these? Yeah. Okay, one more. Last one. Okay, take a look. Even, odd, or neither? Very good. In this class, I didn't hear anybody say odd. A lot of times I do hear odd. Now, why would people think odd at first? 5 and 7 are the only powers you see. But if you have a number without an x, that is the same thing as x to the power of 0. If you graph that, that would give you the same exact graph as not having that. Now, would you say it's even or odd? Well, you already told me this is neither. Good. Okay. Now let's talk about the leading term. 6x to the 7th. Good. 6x to the 7th. That's my leading term right there. And it's a positive 6x to the 7th. Okay. Would that be a S curve or a parabola if it's to the 7th power? S curve. This is going to be an S curve. Is it a increasing S curve or decreasing S curve? Increasing. It would look like this. Whoops, that's, let me make it more angled. There we go. A little bit better. Still not great, but whatever. Okay, tell me about my limits. This one's called H, so I'll call it H of X. Which way is this arrow right here moving? To the right? To the left?
Right.
Right. What symbol means right? Positive infinity. And are we rising, falling, getting flat, or coming to a point? Rising. Okay, how about this limit?
Oh, a limit. H. Yes, negative. Both negative.
Both negative? You mean it goes left and it falls? I agree. Goes left and it falls. Now, if you wanted to, you could practice on this packet. I think I gave you like 6 different problems that you can practice with, if I'm correct, of discovering, without even graphing these in the calculator, you now know what time you could figure out which equation it is. So, for example, looking at the picture, is that an S curve or is that a parabola? It's an S curve. What does that mean about my highest power? It's odd. My highest power has to be an odd. Now, is it a positive S curve or negative S curve? So you're looking for a leading term that's a positive odd power. So that's what you would look for, and you would only have one option where the leading term is a positive odd power. Make sense? There's 6 different of these you could take a look at. But what I'd rather you do is sign in and take a look at your College Board questions first.